Sir, you are live now.
Hello, good evening. Yes. So is the participants there? Hello, good evening. Yes. So what I can do, I can just share the screen, whatever we have covered so far, we can continue discussion on that. In between, if someone joins, definitely they can get in and ask their queries to any particular lecture slide. Okay. So I am just sharing the schedule, what all things that is covered after our live session that was held earlier. Okay. Okay, so this is what we did earlier. So we have already covered the first to fourth module that was discussed in the last live lecture series. Okay, so today we'll be discussing on the fourth module, fifth, sixth, and seventh module. Till here it is already there online, right? These are already there online. I hope you don't have any difficulty appearing for your assignments at least. Assignments are directly related to the videos, so I hope you have already gone through the videos. You can anyway repeat the videos you have in hand and you can appear for the assignment. That should be directly relating to your video lectures, right? So I hope those are quite easy in that case. When it comes to end semester last exam, no, final exam, so it should be normally the way standard UG curriculum of robotics is there. We have planned like that, and the new topics, especially the calibration part of it, that is covered here. So you see, this is the standard one: forward kinematics, inverse kinematics, differential motion analysis. These are standard UG curriculum courses, so that is quite okay with most of you because those are there already in the test book. Whatever test book is prescribed for this course, you have mostly all of them in the test book also. Apart from this, that is industrial robot installation and commissioning, this is specific to our course, and you hardly get any book that actually covers this, right? So this is the reason it is mostly covered in the assignment portion of the course, but not in the end exam. In end exam, you will see very small portion of this that is actually there. So it won't be any rigorous questions based on industrial robot installation, commissioning, mastering a robot, tool center point calibration, orientation calibration. These are very advanced concepts. They are directly relating to industrial robotics. The industrial robotics manual, most of the manual you will see these are already there. Okay, let me show you if I have one. So I'll just share one of the industrial robot manual to discuss with you in detail now. Okay, so you see this is there. Okay, so this is the manual which I am talking about. So if you go through these manuals, this is for KUKA KR5 ARC robot. So this is for KUKA system software that is common to all the KUKA industrial robots. So this is one of the manual where you can find mastering. So you can download these manuals directly from the website of the manufacturers. So if it is KUKA, you can download it from them directly from their website. You may be required to log in as a user. That's all. And maybe you can download it using just as a learner, you can download it. You need not to have that robot in hand in order to get this manual. Most of the time it is like that. So at least in case of KUKA, it is there. So if you go to startup and commissioning, there you will find a specific topic called mastering. mastering. Okay, so mastering methods are there. If you can see this manual clearly, so this is mastering methods that is discussed here. How to put the EMT tool, electronic measuring tool, that is discussed in our video also. Okay, similar figures are there in our videos also. So, but this will just tell you how to perform these mastering. Okay, but the mathematics is not discussed in the manual. But at least you can have a look on these manuals so as to confirm to your robot, maybe whatever you have it in your lab, how this is done. Steps for those is directly given here. Okay, moving, what all steps that actually goes in mastering a robot. This is just for the mastering. Others, installation and commissioning also, if you just go there again, once again, so you can see how a robot is installed. Those standard details are also there. And there comes the calibration of it, defining the tool direction, what is covered in our course also. A robot is made to brush upon the external reference frame from 3 different directions and once from the top also. And finally, this is known as XYZ 4-point method. We have called it a 4-point method only. In case of KUKA, it is referred as XYZ 4-point reference method. So in case of Yaskawa, it is 5-point contact they do, but minimum what is required is at least 3 you should make contact with the external reference point and 1 additional for error checking in now. Okay, so that is required. And ABC world frame, that is for orientation calibration, it is required. So that is also briefed here. This is the reference method that we have discussed, right? So you see only the steps are given here, steps, how to do this. Basically, all the mathematics is done mostly in the robot controller only. When you make it touch, brush upon the external reference frame, the first tool, the known tool and the new tool. Okay, this is the known tool for which you already know the TCP. This is the unknown tool that you have kept. Hope you remember how it is done in our videos. It is already there. So this is known as XYZ reference method. So you see steps are given, but not the mathematics. Same here, when you try to find out the orientation, steps are given in the manual. So 5D method and the 6D method, we also have called them with the same name. Okay, so you see this is all there in robot manuals. Okay, this was directly from these manuals only. Only thing that we have elaborated upon the mathematics behind the procedure which is required to do such calibration, right? So these are a little explicit content of this course, which is not there in the textbook. So looking upon that, we have not kept it thoroughly in the end exam, but definitely it will be there in the assignments. Because in case of assignments, you can directly refer to the video lectures live and you can answer them. So that is the reason it is there in the assignment, but not in the end exam. And formally, maybe in the later years, it will be quite regular stuff in the textbook, and then it can be there in the end exam also. So these are concepts which is not very new though. It is there since I think 20 years. These things are already there in the teach pendant. These advanced steps also for calibrating the tool. No idea why it is not there in the textbook. Okay, but still numericals can be framed out of these steps. They are very excellent example how one can use the transformation, homogeneous transformation matrices and steps to do this sort of calibration. You see, we have almost similar experiments. Those are explained in our course also. So calibration is one of our strengths of this course, and they directly relate to the industrial robot. They directly relate to the industrial robot, you see. And industrial robot practitioners, they day-to-day life, they are using it thoroughly every day. Okay. Forward and inverse is mostly very, very common stuff. Mathematics is there in quite a lot of book also. So it should not be a problem for any one of you. It is there already, and it is covered in our course also thoroughly. So that should be okay. Calibration is something new that I have discussed thoroughly in our video lectures. Difficult to find them in the textbook. Again, robot statics is there. So that is again a textbook thing that you can find it anywhere. Okay, in quite a lot of book, it is quite covered, quite much covered. So later you will see these examples. That is robot dynamics. Again, it is a textbook matter, and load data calibration is not there in the textbook again. Okay, repeatability tests and all. Robot control is a textbook matter, and robot safeties and norms, it is again not there in the book. So these are a few reasons why we have made the assignments more thorough and the end exam quite simpler for most of you, because you can refer to textbook. So this is what is mostly covered in the course. And you see, you should download these type of manual. You see your manual, you see mastering is already there. Calibration. So whatever calibration methods that we have discussed, it is already there for calibrating a linear unit, base calibration. So base calibration is there, fixed tool calibration, right? Tool center point calibration, tool orientation calibration. So these stuffs are already there in the manuals, but definitely not the mathematics part of it. Mathematics, you have to refer to our course only. Okay. So I think with the KUKA manual, it is done. Let me just see if I have any other manuals also which does a similar thing. Okay. Okay, this is for Yaskawa robot. Again, you see you have installation procedure which is defined here. Installation procedure. You see we have demonstrated this quite in detail, quite much in detail, how to install this. I have basically covered with the video that installs exactly this robot. Okay. So these figures, you saw them in the course also, right? All the notes you can find. So again, you can download Yaskawa GP12 or Yaskawa, any other robot manual directly from their website, right? So you see mounting method, location, dust proof, waterproof, those precautions and all is already given. So this is all about installation. Not just this, once you download any manual, you see you will get not just the things that are covered in the course, many other things also you will come to know. How the robot is transported. You see transportation method, where to put the slings, okay? Where are the hooks placed, how to carry it, what is the minimum compact way you can put your robot so that it can be transferred with almost like a very small load on the gears, right? Where to put in the forklift. So these details are also there. That is not covered in our course, how wirings are done. So you will get to learn all those stuff. So this thing we have discussed in our course also. Initial bracket where they have kept, later on this is removed. This is for transportation purpose. So installation covers mounting, location and all. Basic specification, right? So that is there. Mostly this is the robot manual. I may be having other manual also. Okay. And this is for a standard robot calibration and all. It is all there in this manual that you can go through. This is another manual that is for the controller instruction. A little bit about the programming. The pendant is also given. So you will get to know the programming. Programming is covered at the end of our course also. Okay. So that is there. How to take the system backup, system setup, right? Home position, work with the home position, tool data setting. So here you will see how tools are calibrated and tool data is set. So not like KUKA industrial robot. This is a similar robot, 6 degrees of freedom. You see it touches from the 5 different directions. 3 are required, 1 for the error. Additionally, you can take it. It is taking 1 redundant reading. Okay. So similar methods are there to find out the tool center point. Okay. So this is there in this manual also, you see. Okay. Same with the other home position calibration, how home position is calibrated. That is what we call it as mastering of the robot. Okay. Shock detection. So you see a lot of things you will learn once you download any of these industrial robot manual. Okay. So these manuals I have shared it already as a study material for you all to refer. Right, you can definitely go through that, or you can directly download from the manufacturer's website. Okay, that should help you. So I think that is mostly, it requires discussion mostly on calibration issues, because that is not there in the book. Otherwise, it is mostly there in the book. So if at all you have any query, I'll be happy to answer. Otherwise, from our side, I am done. Okay. If you have any query, I'll wait here for another 5 minutes, or else I'll sign off. These are few things that is covered already. So I could see Sheikh is there if he wants to ask anything. Sheikh, if you are shared with Zoom meeting link also, then you can join it there also, so that you can communicate it faster. Here, I say a lot of latency is there. So any further discussion is required, will be here for another 1 or 2 minutes. After that, I'll end the session. What I see, Satish is asking, can you suggest any open source robot simulator for kinematics, which has models of industrial robots? Yes, definitely there are a few. If you can take up open source, means what do you mean? You mean whole of the source code is visible to you? No, there are not any. Okay, but yes, definitely you have a robo analyzer software that is freely downloadable, and that you can use it. We have used it for teaching purpose here also. Robotic is there, VREP is there. Okay, VREP, you can download VREP. There are multiple models that you can download and do kinematics, and you can connect it using Python also, using its API solution, and you can run the robot over there. Even you see, if you have SolidWorks where you can assemble most of the robot manufacturers, they also have their CAD shared on their website. You can download the CAD model, import it to your VREP environment, or you are creating the URDF model and all. Okay, maybe using SolidWorks or any CAD software, you can import them, you can export them finally to the MATLAB's Simulink environment. There you can do it. You can directly do it on SolidWorks using API connectivity, using any Visual Studio or those kind of software. They allow you connect the SolidWorks visual environment to run your code in Python or anything, and that can fetch the joint angle details to the robot in visual. Okay, so the many simulation tools, even ROS can do it. Okay, but none of them are open source in code. Coding you will have to do it. But yes, robotics toolbox is there in MATLAB that can do it much better. Okay, at least a few visible things you can see over there, at least the forward kinematics, inverse and all. Those things are visible, yes. Okay, not especially for industrial robot, it is for many robots. Even for 2R, you can create one, which is not there in the industry. So these are some of them. There are many others also. I'll share a research paper which compares kind of all different simulators, robot simulators. Okay, Satish? So how many of you are appearing for assignments already? Have you appeared for assignments? After Saurabh Biswas, Saurabh, definitely I have recorded these videos are already there online. Yes, yes, definitely I'll try to cover the research aspect of this. Okay. And towards the end, when I will talk about the programming industrial robot, I'll also cover few things like how a research student can utilize industrial robot for their research. Mostly they are kind of very hard-coded kind of stuff which is there in the teach pendant. But yes, you can connect industrial robot with an external tool using their API. Nowadays, it is commonly there in most of the industrial robot. They allow you connecting using SDK or API, and you can make your own code communicate with industrial robot and make the robot run. Like, let's say I have seen people doing brain computer interface. You are using an industrial robot and you have an EMG that is fitted here, EEG which is fitted here, like epoch sensor or those kind of sensors are there with 14, 15 electrodes. You check the intention and make the robot move accordingly. So your own software will process the uh, complete signal, EEG signals, and finally it will find out what is your intention, and finally that fetches the signal uh, to the industrial robot, that communicates that signal to the industrial robot through Ethernet, where it is connected using API or SDK, and industrial robots are doing that. So this is one of the example that I gave you. Same way, whatever research you are doing already, you just need a connection between industrial robot and your standard PC, where you are normally conveniently doing programming since long time. So output of your results of your robot in virtual can get into the real robot. Right. So that is one of the way you can communicate with industrial robot, you can do it. As such, directly programming on teach pendant using robot controller, it is very, very difficult to do research because it is not meant for that. This course mostly covers the intrinsic details of industrial robot. That is, if at all it is saying you do this, and you get to know your tool center point. How? So that is those how, when those things are covered in this course, those intrinsic details, which is not there in the book, but industry, it is regularly used. Those methods are used. So that is what is covered in this course. Okay, so research aspect, I'll try to answer them in much more detail. Maybe if possible, I'll try to have a complete video on research aspects, handling research with industrial robot. This video is due. Thanks a lot for the suggestion. Any other query from anyone? If not, then can we end it here? So I would end here. That's all. Thanks a lot. Thanks a lot for being with me.